When Americans imagine devastating earthquakes, their minds jump to California's San Andreas Fault. Texas rarely enters the conversation. It is a state more commonly associated with hurricanes, tornadoes, droughts, and oil fields than violent ground rupture. Yet beneath its plains, deserts, and booming metropolitan corridors lies a complex network of faults. Some ancient, some reactivated, some increasingly stressed. In recent years, seismic activity in parts of Texas has surged, raising an unsettling question. Could a much larger earthquake strike Texas? The answer is not simple. Texas isn't on a major plate boundary. There's no massive subduction zone offshore. But geology is rarely simple. Ancient tectonic scars combined with modern industrial pressures have created a new seismic danger for Texas. Texas is not located near the edges of tectonic plates, which are the primary sources of seismic activity worldwide. Instead, it lies in the interior of the North American plate, far from the more seismically active regions like California along the Pacific Plate or Alaska. This geographical positioning has contributed to the perception that Texas is relatively immune to earthquakes. However, this perception is misleading. The state is laced with old fault systems formed during past tectonic episodes, some stretching back hundreds of millions of years. One of the most significant geological features influencing Texas today is the Balcones Fault Zone. The Balcones Fault Zone runs in a sweeping arc from near Dallas through Waco, Austin, San Antonio, and toward Del Rio. It formed millions of years ago during the rifting of the Gulf of Mexico. While this fault is not as active as the San Andreas Fault in California, it has the potential to produce earthquakes. Farther west lies the Basin and Range Province, a region characterized by crustal stretching. In far west Texas, near El Paso, faults are more active. The Rio Grande Rift extends north from Mexico through New Mexico into Colorado, but its southern influence affects western Texas. This is not merely theoretical geology. West Texas has experienced measurable seismic activity tied to this broader tectonic environment. Then there is the Permian Basin, one of the most productive oil regions in the world. For decades, it was not known for earthquakes. Today, it is one of the most seismically active areas in the state. Texas may not sit on a plate boundary, but it sits on faults. And faults only need stress to move. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. For most of the 20th century, earthquakes in Texas were rare and typically weak. But beginning in the early 2000s and accelerating dramatically in the 2010s, seismic activity increased in certain regions, particularly around oil and gas production zones. Cities like Midland, Odessa, and areas near the Texas-New Mexico border began experiencing swarms of small earthquakes. Some exceeded magnitude 4. A few surpassed magnitude 5. In 2022, a magnitude 5.4 earthquake struck in West Texas, the strongest recorded in the state in decades. Unlike California's tectonic quakes, many Texas earthquakes appear linked to human activity, specifically wastewater injection. During oil extraction, large volumes of salt water are brought to the surface and injected back underground. This process can increase pore pressure along faults, reducing friction and allowing slippage. Here lies the critical concern. Even if many recent earthquakes are induced, they are still real. They still release stress, and they still reveal where faults exist. The more serious question now is whether a much larger earthquake could follow. Texas is unlikely to experience a magnitude 8 or 9 earthquake. Those require subduction zones or major transform plate boundaries, but magnitude 6 or 7 earthquakes are within the realm of geological possibility. To put that into perspective, a magnitude 6.5 earthquake can cause severe damage near its epicenter, especially in regions with infrastructure not designed for seismic resistance. In 1931, a magnitude 6 earthquake struck near Valentine in West Texas. It caused damage to buildings and was felt across multiple states. At the time, the region was sparsely populated. Today, population growth and infrastructure expansion have transformed parts of Texas into dense urban corridors. Imagine a magnitude 6.5 striking near Midland, or beneath the outskirts of El Paso, or even along a reactivated fault closer to central Texas. Texas buildings, unlike those in California, are not universally constructed with strict seismic codes. Much of the state's infrastructure, from pipelines to highways to industrial facilities, was designed with different hazards in mind. Shaking intensity depends not only on magnitude, but on soil conditions. Soft sediments can amplify seismic waves. Parts of Houston, Dallas, and San Antonio sit atop sedimentary basins that could enhance ground motion. A moderate earthquake in the wrong place could have outsized consequences. If a damaging earthquake were to strike Texas in the near future, West Texas is statistically the most likely region. The Permian Basin's combination of natural faults and industrial injection has created clusters of seismicity. Stress has been introduced into a system of pre-existing faults. Even if injection activity decreases, faults that have already been destabilized may continue adjusting. Additionally, the broader tectonic forces of the basin and range extension continue stretching the crust slowly over time. West Texas is also home to critical energy infrastructure. Oil fields, pipelines, refineries, and storage facilities form a vast industrial network. An earthquake damaging these systems could disrupt energy markets nationally. The earthquake could fracture pipelines, rupture storage tanks, or trigger hazardous material releases. The economic ripple effects could be substantial. Moreover, urban growth in Texas has been explosive. Skyscrapers, high-rise apartments, sprawling suburbs, and complex highway systems define metropolitan regions. Most residents do not consider earthquakes part of daily risk. Emergency preparedness drills focus on hurricanes and floods. Earthquake retrofitting is not common. An unexpected magnitude 6 or 7 near a major Texas city could expose these vulnerabilities dramatically. While West Texas dominates recent seismic headlines, the Gulf Coast introduces another layer of complexity. Coastal sedimentary basins can amplify shaking. Houston, one of the largest metropolitan areas in the United States, is built atop thick sediments deposited by rivers over millennia. These sediments can behave differently than bedrock during seismic waves, potentially increasing surface motion. Additionally, the weight of urban development and subsurface fluid extraction have contributed to land subsidence in parts of the region. Though subsidence is not an earthquake, it reflects changing stress conditions underground. A moderate offshore or inland earthquake affecting the Gulf Coast region could produce unexpected ground responses. And unlike hurricanes, earthquakes offer no days-long warning. Let's imagine a plausible worst-case scenario within realistic bounds. A magnitude 6.7 earthquake strikes in West Texas along a previously stressed fault near the Permian Basin. The rupture extends several miles underground. Shaking damages oil field equipment and fractures pipelines. Power outages spread across multiple counties. Small fires ignite. Simultaneously, infrastructure strain affects natural gas supply lines, feeding power plants elsewhere in Texas. Markets react. Emergency responders deploy across vast distances. The quake is felt as far away as Dallas and Austin. Social media floods with confusion. Many residents experience their first significant earthquake. Damage totals billions, not from collapsed skyscrapers, but from industrial disruption and cascading system failures. This is completely within the realm of geological and economic plausibility. As Texas continues to grow, economically and demographically, its exposure to low probability, high impact risks increases. Seismologists emphasize that Texas is not on the verge of a catastrophic megaquake. Probabilities for large natural earthquakes remain relatively low compared to California. However, they note that induced seismicity has changed the seismic landscape. Energy extraction practices have evolved. Carbon capture and storage projects could introduce new underground injection patterns. Urban sprawl may extend into geologically sensitive zones. The key question is not whether Texas will experience another earthquake. It will. The question is whether it will experience one large enough to test its infrastructure and preparedness, and whether it will be ready when it does. One of the biggest challenges is the lack of public awareness and concern about the risk of earthquakes in Texas. Because the state has not experienced a major earthquake in recent history, many people do not perceive it as a significant threat. This can make it difficult to garner support for preparedness efforts. Earthquakes do not respect reputations. They do not avoid states better known for other disasters. They exploit weaknesses quietly, then suddenly. Texas may never face a magnitude 8 catastrophe, but it does not need one to suffer significant damage. All it would take is one fault, one rupture, one unexpected morning when the ground moves beneath a state that thought it stood far from the edge. And in that moment, the myth of seismic safety would crack, just like the Earth below.